What do you know about the Wireshark? Wireshark is one of the most popular packet analyzing tool that is used by the network engineer in the computer networking industry. This application is totally free. You are free to use the Wireshark without any payment. And moreover, it is very easy to use. As like the other paid network analyzing application, Wireshark is not that much complicated. Anybody can use it easily. So in this chapter, we are going to talk about the Wireshark and I will show you how to use Wireshark application. Welcome to CCNA 200-301, Implementing and Administering Cisco Solution, Chapter number 48, Introduction to Wireshark. In this chapter, we will talk about the Wireshark Packet Analyzer and we will discuss about the Wireshark application platform and its features. Welcome to Irash Academy. In this chapter, we are going to talk about the Wireshark Packet Analyzer. So as I said in the beginning of this video, Wireshark is the most popular packet analyzer in this world. It is free to use and very easy to use. And because of all this reason, Wireshark is widely used by the computer engineer in the computer networking industry. Now here the question is, why do we need to use Wireshark? Why do we need to use a packet analyzer? Packet analyzer has multiple usage. I will explain its usage with the help of an example. Consider a network diagram that is showing in the screen. There you can see one computer is connected to one network switch which is called switch 1 and one server is connected to another network switch called switch 2 and the switch 1 and switch 2 are connected to a router. So from this network diagram we can understand that the PC and the server are in different network because they are connected to two different interfaces of the router and we know router is using to connect the dissimilar networks. So just imagine switch 1 is a network and switch 2 is another network. Now the computer from the network 1 is trying to send some traffic to the server which is located in the network 2. So it sends the traffic and it is passing through the switch, router and second switch, then it's reached to the server. Maybe it is a database query or maybe it's a requesting some information to the application. So as soon as the server 2 receive that query, it sends the response back to the PC and that response is also passing through the switch 2, then the router, then the switch 1 and finally it reach to the PC. So here what would be the time it will take the request to travel from PC to server and the response to travel from server to PC. It is depend upon your network speed and the size of the data. Normally in the current computer world it won't take that much time. Just imagine normally it takes 3 seconds to travel from PC to server and it takes another 3 seconds to travel from server to PC. So within 6 seconds we should get the response. We should get the result, right? But what if it is not happening? You are not getting the response from the server within 3 seconds. Just imagine you send the traffic from your PC and you get the response after 20 seconds. Then what would be the reason? Where is the issue? Issue may be with this PC. Maybe this PC is taking too much time to send the request. Once the request is out of the PC interface, then only it can travel through the network and reach to the server. So the problem may be with the PC. Or what if the PC is working fine and this network switch is faulty? It is not processing the data properly. Or if this router is the reason to slow down the network. Or again, what if it is the switch 2 making the network slow? Another possibility, what about the server? When the PC send the request to the server, maybe the server receive in proper time in 3 seconds. But what if it is taking too much time to send the query back because of some internal issue? So how do we understand where is the problem exist? To understand the problem, you need to track the packet. You need to follow the packet and understand where it is getting stuck. For this purpose, we can use the packet analyzer. So by using Wireshark, we can analyze the packet that passing through the PC and switch 1 and understand what is going on. It gives you a timestamp when the PC send the data and when it reach to the switch. If this part is okay, then you can analyze the next interface, the path between the switch 1 and router 1. If that is okay, you can go to the next interface, the path between the router and switch, and you can even go to the final path, the path between the switch 2 and server. So by analyzing the packet at each path, you can understand what is happening in the communication between these network devices. So you will find somewhere at a point that the sender send the traffic, but it is not receiving the response in proper time. Then you can easily understand where this network traffic is getting stuck. Then you can check in the receiver side why it is not sending the packet back. So in this way, by following the packet that you are sending through a network, you can travel along with the packet analyzer and find out where is this issue. And we can use the Wireshark for this purpose. And not only for this purpose, it has many other usage also. You can use it for network troubleshooting. You can use to analyze the data. You can use to decode the data. You can check the communication between two devices and so many uses. Now when we talk about the Wireshark capture, what are the information that the Wireshark can capture? I will explain that. For that, I am going to take you in a network diagram that is shown in the picture. Here you can see two different networks. The network on left side contains two PC and two IP phone. The network at the right side contains two PC, two IP phone and one server. And these two networks are connected with the help of a router. Now let me tell you what are the information that we can capture with the help of Wireshark. Just assume the PC1 is sending some traffic to PC3. And by using the Wireshark, we can understand what is the data they sent each other. We can decode the data and understand what is that communication. Now another example, if the phone 1 making a call to the phone 4 and these users are talking together, can the Wireshark understand what they are talking together? Yes, with the help of Wireshark, we can decode the voice. We can understand the conversation. Another example, the PC2 is sending some communication to the application which is located in the server. Here by using Wireshark, we can understand what kind of communication is happening between PC1 and the application in that server. What if this PC4 try to access the internet and download some image from the internet? Can the Wireshark capture what is that? Yes, of course. With the help of Wireshark, we can capture that packet and download that graphics accordingly. So basically saying, with the help of Wireshark, we can track each and every communication that happening in a network. Now here we were talking about getting the information that is happening between multiple devices and multiple users. Like understanding the communication between the devices, decoding the telephonic conversation and decoding the data that they have downloaded from the internet. But all of this action that you are using with the help of Wireshark, is it allowed? It is not allowed unless you are authorized to do that in your organization, because you are playing with others' information. You are doing some eavesdropping or data stealing between the devices and the user. So if you are not authorized to do that thing, then stay away from this kind of action. It may cause the legal action against you. But if your organization provide you the authorization to do that, then you can do it as part of your job, unless you are not allowed to do that. So be careful when you're using the Wireshark to decode the information that is happening with others. Now let's explore the graphical user interface of Wireshark. In the Wireshark application, there are 7 sections we need to take care of. The section number 1 is main menu. Section number 2, main toolbar. Section number 3, display filter area. Section number 4, packet list pane. Section number 5, packet details pane. Section number 6, packet bytes pane, and the section number 7, status bar. So these are the 7 major areas in the Wireshark application. So let's see where is this area located. This picture shows the Wireshark application interface. And here at the top side, you can see multiple menu options available, and this area is called main menu. And below the main menu, you can see multiple tools available, and this section is called main toolbar. And below the main toolbar, there is another section called display filter area. This is the area we are using to filter our capture. And below the display filter area, there is a vast area which is called packet list pane. This is the area where all the captured packets are displayed. And below the packet list pane, you can see another area which is called packet details pane. This section displays the details of each packet that we are selected. And at right side of packet details pane, there is another area which is called packet bytes pane. So for each packet detail that we select, we can see the captured byte in the packet bytes pane. And at the bottom area, there is another area which is called the status bar. This is the area where status of our capture or status of our selection is displayed. So these are the main 7 sections in the Wireshark application. Now let me open the Wireshark application and show you this area in real time. So here let me open the Wireshark application in my computer. So I am opening the Wireshark application from my taskbar. Now the Wireshark application is open. So as soon as I open Wireshark application, you can see the capture option is available here. And how do we perform a capture? To perform a packet capture, we need to select the network interface from our computer. Which network interface we need to capture? So here Ethernet 3, this is my network interface that I am going to capture. Here you can see some of the interface showing some graph here that indicate that there is a packet communication happening in that interface. That means that interface is connected to network or any other device. On the other hand, you can see the other local area connection here. There is no communication happening because it is blank. It is not connected to anywhere. So here Ethernet 3 is my main network interface that is connected to the network. So I am going to select that for packet capturing. So here I can select the network interface, then double click on it, then the capture start. And here you can see the capture started, and whatever the packet capture, it can display in this application. So here I am going to stop the capture by using the stop button. So let me click the stop button. Now the capturing process is stopped. So let me give you an introduction about the Wireshark application and its different sections. So as we said, at the top of the application you can see multiple menu options like file, edit, view, go, capture, analyze, statistics, telephony, wireless, tools, and help. So these are the main menu of this application, and this area is called main menu. And below the main menu there are multiple tools available like start the capture, stop the capture, and close the capture, zoom option, and other navigation option. These are called tools. And this area where these tools displayed is called main toolbar. And below the main toolbar there is another area which is called display filter. So when you capture the packet, there may be thousands of packets. So from this thousands of packet, if you want to filter only some specific packets, for example, if you want to filter only the ARP packet, or if you want to filter only the DHCP packet or DNS packet, then this display filter help you to filter by using that specific protocol or the IP address. So here when you apply the filter, then the application only display those filter from the total captured packets. So this is what it's called, display filter. And below the display filter there is a vast area. This occupies the half of the application screen, which is called packet list pane. The packet list pane is the area where all the captured packets are displayed. Here you can see in the packet list multiple packets are captured, and when you select, it is getting selected, and each packet is captured with a serial number starting from 1 2 and it is going. So each packet has numbered, and there is a timestamp. At what time this packet is captured, there is a timestamp also available. Then the source IP address, from which source IP address this packet is generated, and then the destination area to which IP address this packet is going. Then what is the protocol used by that packet. Here you can see TCP, UDP, and DNS, etc. Then the length, you can see here the length of the packet. Here you can see 52254, this is the length of the packet. And the information. This provides the more information about that packet. For example, here you can see information it is going from port 51518, it is going to 443, and the length is 29. And here you can see another information like a standard query response, tracker, etc. So this provides more information. So this is the default section available in the packet list pane. And other than this, we can customize and add the required field here. You can add fields, you can remove fields, and you can customize the field that you can do. And below the packet list pane, there is another area which is called packet details pane. So each packet we can see in the packet list pane, and when you select each packet, this packet detail pane provide more detail about that packet. For example, now I am going to select this packet, okay, and here it is displaying packet details like domain name, system, and user datagram protocol, internet protocol, Ethernet, frame, and all informations are provided here. And right side of the packet details pane, there is a packet bytes pane. So when you select each packet detail here, then that packet bytes are displayed in the packet bytes pane. For each packet you selected, that detail is showing in the packet details pane, and for each packet detail, the packet bytes are displayed in the packet bytes pane. So all these three are interrelated. For each selection, the specific selection from the other pane you can see. And at bottom of this application, you can see the status bar. So this area is that status bar, and it will show the status of the capture. Here you can see the packet 2762 is captured and dropped is 0. Now the packet is dropped. And when you select each packets, the status bar display the details about that packet. For example, now I selected the Ethernet, and the status bar shows this Ethernet, this packet is 40 bytes size. And when I select the bytes from the packet bytes pane, you can see this is 2 byte. And when I select a packet from the packet list pane, in according to that, the status bar display the specification about that packet. So these are the main 7 areas that is available in the Wireshark application. And with the help of all these 7 areas, we can analyze the packet in more efficient way. Now let me talk about the toolbar section. As you can see, I have done one capture before. Okay. Now, if I need to close this capture, there is an option in the toolbar. Close this capture file. So just click this, then it is asking whether you want to save this capture or not. So here I am going to save this capture. So I click save, then select my document and provide one name called test capture. Okay, then I click save. So my captured file, it is saved in that specific location. Now come back to the toolbar. Here the first option, which is called start capturing packet. And when you click here, the Wireshark start capturing again. So let me click here. So now it is capturing. So if you want to stop the capture, the second option is available here, stop the capturing packet. Just click stop button, so your capture is stopped. And if you want to capture it again, go back to the first option, and you can use it alternatively as per your requirement. Now there is a third option which is called restart current capture. Let me close this without saving. Once if you start the capture, after some time you realize that you didn't start the communication from the PC. Here you are doing some troubleshooting. For that purpose you need to start some communication from the PC. But after you click the start button, then only you realize that you didn't start the communication from that PC for capturing. So in that case, you can either go to stop button, then start the communication, then start it again, or directly you can start the communication from that laptop or PC and click on restart current capture. So it will restart from the beginning. So whatever the captured packet from the previous capture, it will not be saved. Instead, it will start a fresh capture. So this is the use of button restart current capture. Now let me close the capturing here. Now another option you can see, the capture option. So this interface provides you more control over the capture option. So when you click on the capture option, you can see input. Under input section, you can select which network interface you need to include in this Wireshark application for capturing purpose. Here you can see the multiple network interfaces are available in my computer, so it display all the interface. So here maybe 1 or 2 interface may be active, the other may be inactive. So you can go to the manage interface option and remove the unwanted interfaces from this option. So in my case, my Ethernet 3 is the active interface. So I can remove all other interface from this manage interface option from capturing, so that it will only capture from the Ethernet 3. Let me press OK. Now you can see only my main interface is selected here and there is no other interface available. If you expand this thing, you can see the IP address and MAC address of my interface. Now if you go to the output, here there are multiple options available. First of all, you can capture into permanent file. So instead of you are capturing and stopping it, then saving it as per your requirement, you can permanently capture on this interface and save that into a location. So from using the browse button, you can select a location and save it here. So after that, whatever you capture, it will save automatically into that file. If you don't want to give any name here, then leave it blank. And from the output format, you can use the PCA PNG format or PCAP format. By default, it is selected PCA PNG, so I select that one. Now here is the beauty. If you want to create the new file automatically, you can select here the tick mark. And here multiple options are available for creating the new file. So depend upon your requirement, you can select that option which is applicable to you. So here the first option is based on the number of packet you can create new file. For example, you can make an option like for each 1000 packet the new file need to be created. Then you can select that option from here and type here 1000. So for each 1000 packet another new capture file will be saved in the location. You can select the option based on the size of the file. For example, here kilobyte, megabyte, gigabyte is available. So if you select from here megabyte, you can select for each specific size the new file need to be created. For example, here I put 5 MB. So what will happen when the captured file reach 5 MB, then another file will be created, and when that file reach 5 MB another file will be created. That means for each specified size, when it exceed, the new files are created. Then another option is based on the time. Here you can select the second, minutes and hour. So I can say for each 10 minutes new file need to be created. So for each 10-minute capture, this will be saved as a new files. Then you can select the interval based on the second, minute and hour. I can say that for 2 hours new files need to be created. So when you start capturing, for each 2 hours new files are getting created. And the compression type you can select none or zip file. By default it is none. And the file naming pattern also you can select. So here I am going to choose the default one. So this is how you can save the captured file automatically. And when you go to option, here there are multiple options are available. The first one of the option is update the list of packet in real time, that we have selected by default. Then another option is available, automatically scroll during the live capture. So when the packets are capturing, by default the packet list pane display the latest packet captured. So that means it is going scrolling down. So if you want to remove that thing, you can deselect this, and if you want to enable, you can select that thing. And show capture information during live capture, this is up to the user if you want to select it or not. Then under the name resolution another option is available, that is called resolve MAC address. So when you enable this option, the Wireshark automatically detect the MAC address of the source and destination devices and resolve that accordingly. For example, if the destination device is a Cisco router, then the Wireshark can get the MAC address of that destination and resolve it and understand it is a Cisco router, and it can display in our result the destination is a Cisco device. Then another options are available, resolve network name. Network name also you can resolve if it is required. Resolve transport name, that is also possible. So after you made necessary changes, just click start so that it will be saved. So here I am not going to change anything. I am using all the options by default. So let me close this. The next tool is open the capture file. This tool helps you to open any captured file in the past, maybe using the same PC or maybe somebody else captured with another device. That doesn't matter. If it is a Wireshark file, you can use this option and open that. So here I have captured some packet previously, save it in my document. So let me go here and open it. So here when I open it, it is asking to browse the location. So under my document I have captured the previous capturing, that is called test capture. Select the capture, then open. So it is asking, do you want to save the current capture or not? So here I am selecting to close it without saving. So as soon as I close, my previously captured file displayed here. As you can see, this is my previously captured file. So in this way you can open a previously captured packets. Now here is the option that we discussed earlier, close the capture file. So if you wish to close the current capture file, you can use this option and it will be disappeared. Let me capture it again. Now here another option is save this capture file. So you have started capturing and you want to save it, you can use this option, save this capture file. So it will ask you again, where do you want to save and what is a file name. So I am going to put a file name test2, then save it. So it will be saved into that location. Now another option is reload this file. So if you want to reload this file, just click it. So it will be reloaded from the beginning. Now another option available is find a packet. So when you click this option, find a packet, there is an extra box is displayed. This box is entirely different from the display filter box. This is a new box appear when I use this find option. So here click the find option, and from here I want to select only the ARP protocol. So I can select the ARP here, select, then click on find. So here you can see it takes you to the ARP, and if you click again find, then it will take you to the next ARP packet. And in this way you can go up and down and only look for the packet of ARP. Now here, instead of ARP, if I click DNS, let me see if it is displaying anything. Click on find, and there is no DNS matching with this thing. So let me put TCP, then click on find. See, now it takes to me the nearest TCP packet. When I click again, it is taking to the next packet, next packet, next packet. In that way it is going packet to packet as per our find option. So let me cancel the find option from here. Another option is navigation option. For example, now I have select the packet number 5, and by using this navigation option I can go to the previous packet or I can go to the next packet. So when I select the previous packet, it is going to fourth packet, third packet, second packet, in that way. And when I use the opposite option, like go to the next packet, it is going to the next packet like 3, 4, 5, 6, 7, in that way. So this is the navigation tools. Now another option is available. If you want to go to a specific packet, you can mention that packet number here. For example, now I want to go to 100th packet. So let me type 100 here, then click on go to packet. It takes me to the 100th packet. And in that way, if I want to go to the second packet, I can select the second from here, then go to packet. It takes me to the second packet. So in this way, you can navigate into the right packet as per your requirement. Another option is go to the first packet and goes to the last packet. So when you select go to the last packet, it takes you to the last of this capture file, that is 2653rd packet. This is the last packet available in our capture. So it's went there. Now if I want to go to the first packet, go to the first packet, just click on the first packet, then it takes me to the first packet that I have captured. Now if you are looking at the packet list pane, you can see the number of packet is available in the first column, second column timestamp, then there is a source IP address, then there is a destination IP address, protocol length, info, etc. So these information are displaying in the column, and sometimes there is a possibility like column can be collapsed. So here you can increase the column width manually by using your mouse. You can increase in this way, and in the same way you can decrease also. Now I am talking about one option available in the Wireshark tool, that is called resize packet list column to fit the content. And when you click that option, all the columns are getting resized as per the content available in that packet. So there is no conflict, no interference, anything. So in this way you can arrange your packet list pane. Now another option I would like to discuss is automatically scroll to the last packet during the live capture. So when you do the live capturing, by default the packet list pane is getting scrolled to the last packet it is captured. So if you want to avoid that thing, you can toggle this option so that it toggle between automatically scrolling option and no scrolling option during the live packet capturing. Now automatically scrolling is enabled. Now when I capture something, you can see the packet list pane is displaying the latest packet that it is captured, and it is scrolling down. Let me stop this. And when you disable this option, there is no automatic scrolling available. It will stay where it is staying. But that doesn't mean that the application is not capturing. Application is actually capturing, but it is not displaying in the screen because automatically scrolling is disabled. So let me show that thing. Let me capture it again. Continue without saving. Now can you see the packets are scrolling down? No, because it is displaying only from the first packet. It is not scrolling down because I have disabled that option. Now if you enable that option again, see, now you can see it is scrolling down to the last packet it is captured. Let me stop this thing. So this option is as per the user requirement. If you want to use it, you can use it, but it doesn't make any effect in the capturing process. Now another option I want to discuss is, if you see the capture packet, you can see some of the packet in blue color, some of them are in black, some of them are in violet color. Multiple colors are available in this packet. Most of them are blue color because it is UDP. You can see here multiple colors available in this packet. So this coloring part is to recognize the packet easily. This coloring is not provided randomly. There is some reason for this coloring concept. By using this coloring, you can decide some specific type of packet easily. That's why the Wireshark provide this coloring option to the all captured packet. With the help of this color, you can understand what is this packet, what kind of packet. Is it a packet? Is it a real packet, or it's an error message or something like that? So if you don't want to use the coloring concept to the captured packet, you can disable the coloring concept by using this option, which is called draw packet using your coloring rules. Just disable the option. So none of the packets are displayed in color. Instead, every packets are displayed in black and white. There is no coloring available. So in this way, it is very difficult to identify the packet, but if you want to use in this way, you can use it. Let me enable the coloring option. So all the colors are come back to the captured packet. Now another option is zoom option. Wireshark application provide the font size by default, and if you are not able to read the content, or if you want to enlarge the content, you can use it by using the enlarge option. Just click on this plus sign, then you can see the fonts are getting enlarged and you can read it properly. Now what if you want to reduce the font size, or you want to unzoom the display? Then you can use this minus option. Click here to reduce it. In this way you can reduce the size of the font. And what if you want to get back the default display option, default size of the font that provided by Wireshark? Then here is the option which is called return the main window text to its normal size. So just click here. So all the window will come to normal size. And this resize packet list column to fit content we already discussed. Now another option I want to tell you is this last option, which is called reset layout to default size. Why do we want to reset the layout to its default size? So as you can see here, there is a packet list pane and packet details pane, packet bytes pane, and when we are working in the Wireshark, we can change the size of that pane as per our requirement. For example, I can reduce the packet detail pane and provide more visibility to the packet bytes pane, or I can reduce both the packet detail and bytes pane and give the more visibility to the packet list pane. So after all this change, what if I want to get the default layout? What should I do? So this option is help you to get your default layout, and this option name is reset layout to default size. Just click on it and here we go. All of our layout we got as it is in the default of Wireshark. So this is the detailed description of the main toolbar that available in the Wireshark, and with the help of these tools you can perform an effective capture and you can administer the captured file. Another important point that I need to tell you is the units of data in a network. For example, I have selected one packets from here. This is the packet going from the source IP address 192.168.1.135 into destination 190.215.178.240. So when I select this packet here, I got its packet detail pane. So in this packet detail pane, you can see multiple options are available here. These indicate the packet encapsulation at the different layer of TCP IP model. And when we talk about the TCP IP model, there are three main units of data. Let me explain that. So let's talk about the unit of data in a network. So how do we represent a network? We represent the network with the help of OSI model or TCP IP model. And when we talk about the network communication through this model, the data is categorized into three main units. They are segments, packets, and frames. So when the data is passing through the TCP model or OSI model, it is passing through the multiple layers. There are multiple layers called physical data link, network, transport, session, presentation, application. If it is in the OSI model, or if it is in the TCP IP model, it is the network access layer, internet layer, transport layer, and application layer. So when this data passing through all of these layers, they are called in the different name. For example, when the data is passing through the transport layer, it is called segments. So you may be asking the question, what is the name of the data in the application layer? So the application layer in TCP IP, or the accumulation of application layer, presentation layer, and session layer, in the OSI model are considered the operating system layer, the actual network layer starting from the transport layer. So when the data passing from the application layer into transport layer, it's called segment. And when the data pass from the transport layer into the network layer, it's called packets. And when the same data passing through the data link layer or physical layer or in the network access layer that we call in TCP/IP model, then there it is called frames. So these are the three main units of data. Here the data doesn't change. It only transfers from one layer to another layer. But when it reaches to a different layer, then its name is getting changed. Its unit is getting changed. That is the only thing. Even there is three major units of this data encapsulation like segments, packet and frame. Basically, we call the data as packets in everywhere. Now let's come back to our Wireshark application and its interfaces. Now I have selected one packet here, packet number 22. And as soon as I select the packet number 22, the packet details pane display all the details about that packet here. So here you can see multiple options are available called frame, Ethernet, Internet Protocol, user datagram and the data. So here when you select the each section, it's representing packet bytes are displayed under the packet bytes pane on the right side here. So here you can see there are multiple sub options are available for each packet. Under the frame there is a interface detail that is also you can expand and see more information. And if you go to Ethernet, there is a destination and source information. More details are available that you can collapse or expand. And here also under Internet Protocol, there are sub options are available that also you can expand. In this way, you can expand and collapse the information as you want. But there is an option to collapse or expand all the information and sub option available in the packet details pane. For that, you need to right click here at the packet detail pane. Then there is an option collapse subtrees. When you click collapse subtrees, only that option is collapsed, but the others are still remain same. So in this way, for each information you can go and collapse the subtree. And if you want to expand, right click, then expand the subtree. So in this way, you need to go to each option and collapse and expand as per your requirement. But with the help of a single option, you can collapse all the information or you can expand all the information. For that, here is the option expand all, which expand all the trees and the subtrees. And if you want to collapse, again, select the collapse all option. So all the trees and subtrees are collapsed. So in this way, you can manage your requirement. Now let me take you to the Ethernet option here. Under the Ethernet you can see the destination and source. Here source you can see gigabyte tech, and this is the MAC address of source device. And this source device is my computer, the one which I am using right now. And see the destination, it is called Linksys USA. And this is the MAC address of the destination. And this destination is my internet router. So how the Wireshark know my PC interface is gigabyte and the destination device is Linksys brand router? Simply saying with the help of the MAC address. Because in the MAC address, the first 24 bit, it represents the manufacturer of that interface. So here the 74:12:13 is represent Linksys. So the Wireshark easily identify this device is a Linksys device. And in the same way, it identify the manufacturer gigabyte also from this MAC address. So this is how the Wireshark identify the source and destination devices. And if you go to the capture button here is the option. Under the option, there is one option, resolve MAC address. I have enabled this resolve MAC address option. That's why the Wireshark able to identify the manufacturer or the interface or the device. If I remove this option, then Wireshark is no more able to resolve the MAC address and identify the manufacturer. So based on your requirement, how the Wireshark need to capture and display the packets, you can choose the option accordingly. Now in the Wireshark, you can see there are the basic column available is the number of the packet, timestamp, source, destination, protocol, length and information. So what if you want to add an additional column into this thing? You can add additional column as per your requirement. So if I want to add any column based on any parameter in this packet details pane, I can select that parameter. For example, here I selected the source port 51519. So I am going to create a new column where this source port is displayed. So I need to right click on this source port option, then click here apply as a column. So as soon as I click apply as a column, here one new column has been added which is called source port, and here all the source port of that packet it is displayed here because I selected a new column based on the source port. Now if I want to select based on the destination, then I need to click here, then select, right click, then go to apply as column, and when I do that thing, it displays the destination device brand, the manufacturer, because I selected the manufacturer option from here and add as a column. So in this way, as per your requirement, what are the parameter you need to add as a column, you need to right click on it and apply as a column, then that information is available here. Now what if you want to remove the column that you don't need? Then right click on that column, then from here just deselect that column. For example, now I don't want to use the destination information that I have added here. I can deselect that, then it will be disappear. So in this way you can add column and you can remove the column. So same like adding a column based on a parameter that you would like, you can also filter your captured packet. For example, now let me go to the Ethernet and Internet protocol here. Here you can see Internet protocol, source and destination, everything is mentioned here. Now if I go to frame, here, now if you look here under the Ethernet, you can see the source is saying Linksys USA and the MAC address of my internet router. So here, what if I want to filter this captured packet and only display the packets wherever the source is my internet router? So right click here, then apply as filter, then click on selected. And as soon as I do that thing, you can see here on the top under the display filter area, what is it saying? It's saying Ethernet source equal to 74.121.3.146b38, which is the MAC address of my Linksys router. So one display filter is applied on the display filter, and as a result the packet list pane is filtered based on this filter. What was the filter? The filter says the source should be my Linksys router and destination doesn't matter. From my internet router coming as a source, it will display all the packets by using this filter. Now if I want to do another filter based on the frame number, see here I am going to use this frame number based on the frame number. I can select the frame number 227, then right click, apply as filter. Then here we already applied one filter, and this thing we need to apply as an additional filter over that filter. So here if you simply click selected, what will happen? The previous filter will be disabled and new filter will be enabled. But if you want to use both the filter, then you need to go to and selected option. So when you click and selected option, these two filter will be applied in our display filter and only that specific information will be displayed. So in this way you can use this filter option as per your requirement. Either you can create a new filter or you can add another filter with the previous filter by using all of this option. And here when you use and selected, the filter A and filter B should match and only that result you will get. But when you select the or selected, either filter A or filter B, both should be matching, that result you will get. So in this way you can select the filter as per your requirement. So in this chapter we have discussed about the Wireshark packet analyzer, and we have discussed about the Wireshark application platform and basic features. Thank you very much for watching, and subscribe to the channel for more videos. Enhance your skill using Wireshark Academy.